The revision snapshot for straight line graphs is the following. That's your formula. Remember, that's the gradient, that's the y-intercept, and when you're drawing it, you can just put that down straight away if you use the dual intercept method. Graphs can also be written as f of x, or g of x, or h of x, or j of x, and that is another way of saying y. So at any moment you can change that into a y and it'll still work. 3 ways of doing the graphs when you're drawing them. Table method. Remember that you can use the calculator, which is the safest thing to do in a test because that eliminates errors. You're going to substitute some negative, a 0, and some positives, and you're going to get it onto table mode. You're going to see the f of x equals. You're going to enter your formula. Don't forget the alpha button will give you that x that you need. You're going to start with a number that's negative. You're going to end with one that's positive. You're probably going to go in intervals of 1. You need to enter that data to be able to draw. When you draw, don't forget to plot points. Make sure they connect to be a very straight line and manipulate it if it doesn't work that way. And then label your graph nicely and label the points that you've plotted. Your other method is to use the dual intercept method, where you let x equal 0 to get your y-intercept, or you can just read it off the graph, it's the q value. You then let y equal 0 to get your x-intercept. When you get that, you plot it. Please write them down as points before you plot them, and in that way you won't confuse it with finding the point of intersection of two graphs. The third method deals with a gradient, and just a reminder what the gradient does. The gradient, if it's a high number, affects the slope. The slope is more steep if it is a high number, and it is more shallow or less steep if it is a low number. If it is negative, then the graph slopes to the left and it is a decreasing function, and if it is positive, then the graph slopes to the right and it is an increasing function. Your third method then involves plotting the intercept and then moving down with your pencil on your axes by the fraction that you've created out of the a value, the gradient. So we turn it into a fraction, we make sure the negative's at the top, and then we move down or up depending on if that's positive or negative, but the one at the bottom we always move to the right. You then have the intercept, you move across and down or up and across to get your other point. You put the other point down, connect the dots, label everything. Your gradient formula is the change in y over change in x. This is what we're using for that, and this is the formula to use when you have to calculate the gradient, which you will need to do if you are going to find the formula for a straight line. So if they give you the gradient and a point, you can sub everything in and get out your answer for q, and then don't forget to put it in this format. You've got the y and the x, and then the a and the q value given numbers. If they don't give you that and you've got 2 points, you can first calculate the gradient using that formula and then sub in your point, or you can use this formula straight if you've got 2 points. The other thing that you have to do with straight lines is you've got to find the point of intersection. You get 2 graphs. You need to make their 2 equations equal, so let that be y, let that be y. Equate the 2 things that are on the right hand side and solve simultaneous equations. You're going to get out the x coordinate. That's not enough. You've got to sub that back and get out the y coordinate. Once you've done that, you have the point where those 2 graphs intersect. Lastly, a horizontal straight line is one that goes y equals 5 or y equals negative 3 or something like that. It'll be a y equals number graph. It'll look like that, and no matter what the x value is, the y value will stay the same. The gradient is 0. For a vertical graph, it'll be an x equals number graph for the same reason. No matter what the y value is, the x will always be the same, and the gradient will be undefined.